Okay, today we'll be talking about polynomial division using Polyduko and long division. Polyduko is just a game using our generic rectangles that we did before that we can actually factor higher degree polynomials. Now, long division is also an option for that, and I'll show both. But I know the book will have you go through some Polydukos, and we're not really too particular on which one you use. So really what the goal is we might have something like this where I'm taking a cubic, this 6x cubed, so on and so forth, and trying to divide it by 2x plus 5. We can do that with a generic rectangle because when we expand this, we'll find these three terms here, these three shaded boxes, and it should expand to our original. So it's kind of like we're looking at division as multiplication. So for example, to set up a Polyduko, we put our dividend, or sorry, not dividend, what we're dividing by our divisor in this left column, and seeing what we're going to divide or multiply to get to these final terms. So I have the 6x cubed plus 7x squared minus 16x and plus 10. The location of those isn't too important, but the 2x plus 5 spot is. Because what I'm going to do is I'm going to put something in this box to make the dimensions of this box to get to that lead term. So I'm thinking, what do I multiply 2x by to get a 6x cubed? So in this case, if I multiply by 3x squared, I would get, when multiplied together, I would get a 6x cubed. By putting that, though, I notice that it gets me more terms. That now I can find the dimension or find the actual area of this box. So 3x squared times 5x is a 15x squared. And this is where maybe if you're new to Polyduko, where there's a little bit of a struggle because I have 15x squared and it's like, well, am I just guessing to get to these? Well, we'll take a step back and think, well, whatever is in these boxes has to expand to this. So I'm thinking for the red here, I have 15x squared and I have to get to 7x squared. So in this box here, I have to think, well, when I add these two together, it gets to 7x. I have to subtract 8x squared. So again, the combination of these colors, I'm going to try to color code it for you. They have to end up being this. So I can fill that in to know, you know what, it has to be a negative 8x squared. But then I go back to finding the dimensions of the top. What times 2x will get me negative 8x squared? That would be a negative 4x. And then fill in what you have. A negative 4x times a positive 5 is a negative 20x. And then again, thinking, okay, now I got to get to negative 16x squared. If I add 4x, that will give me a negative 16x squared. And then we'll go back to black here. That I'm thinking, what do I multiply 2x by to get 4x? Just a positive 2. And then I get this positive 10, which is awesome because I know then it divides in evenly. I don't have a remainder. So my final answer then, if I divide this cubic by a linear, I should get a quadratic, and in fact it is 3x squared minus 4x plus 2. And another way to think of that or write that is, well, that's the same as 2x plus 5, this right here, like if it was in factored form times this, is 3x squared minus 4x plus 2. So we're going to go backwards in our generic rectangle. I'll do one more example of that. If you feel good with that, you can fast forward to the long division if you need. So just setting up the box is sometimes, again, a struggle. I have a 3x and I have a negative 1. And I'm going to just put this generic rectangle here. And sometimes I don't know how far it's going to go. I kind of leave the spots open. But I know I'm going to have to get to 6x to the 4th this time, minus 5x cubed plus 10x squared minus 18x plus 5. So again, in the upper left here, I want to be thinking, what do I multiply by to get a 6x to the 4th? I would get 2x cubed, which gets me that 6x to the 4th. But then I have a negative 2x cubed. From there, I'm thinking, okay, I got negative 2x cubed. How am I going to get to negative 5x cubed? I subtract 3x cubed, which helps me then find the top dimension here. A 3x times a negative x squared will get me a negative 3x cubed. So then I multiply by negative 1, which gets me an x squared. And I think to myself, what would get me to a positive 10x squared? That would be 9x squared, Looks like I'm going to multiply by a positive 3x to get 9x, negative 3x there. And then what will get me to negative x squared, or just negative 18x, sorry, would be a negative 15x, which looks like it's going to work out pretty well because that would be a negative 5. A negative 5 times a negative 5. Or negative 5 times a negative 1 is a positive 5, so it evened out. So my final answer would be this top cubic as my dividend, or what have my quotient that I divided into there. Then we have long division. It's just another way, a different way to divide. I would be dividing x minus 3 into x cubed plus x squared minus 14x plus 3. Similar questions, but it's just taking the rectangle out of it. And if you remember how to divide numbers using long division, which I know in the calculator era maybe has been lost a little bit, you can look at maybe videos for numbers, but we're doing the same steps of that. So I want to be thinking again, well, how many times, or how many times does x minus 3 go into this? Well, I just break it up that, well, how many times does x minus 3 go into x cubed? So I'm thinking of, again, what would multiply that x to get me an x cubed, but I have this negative 3x. So I have to think, well, I'm chipping away at it, so I have a negative 3x squared. But the big thing from this, when we're chipping away at it, is I'm subtracting. Now, a common mistake, maybe if it helps, put parentheses, because I got to be thinking x cubed minus x cubed, that's gone. But x squared minus a negative 3x, that's where a lot of people put a negative 2x here. That's unfortunately, be careful, it's going to be a 4x. Then I restart. Okay, I'm thinking, okay, how many times does, oh, I've got to bring this down as well, because we're chipping away at the whole thing. You can put the plus 3 if you want. We're just moving everything down, but there probably won't be anything with the plus 3. So I'm chipping away again. So I chip away at this front term. If I multiply by positive 4x, that will get me that 4x cubed, or squared. You just have to have this first term gone and see what happens. So then I would get a negative 12x, but I'm subtracting from there. So that's 0. And then if negative 14 minus a negative 12 is a negative 2x, and then bring down that positive 3, chipping away at the whole big equation. So lastly, I would have to subtract 2, and then I get a negative 2x, and it looks like plus 6. It looks like this one has a remainder, which in our terms so far is okay. We'll say, eventually when you get to pre-calc and things like that, we would have a minus 3 over x minus 3. But a lot of times you'll get a 0 here, and this would be your quotient. That if I took x minus 3 times this, it would get me these lead terms. So hopefully that helped out.